All right, everyone, welcome to Chapter 13. Chapter 13 is all about achieving energy stability. And in Part 1, we are going to focus on renewable energy. And we're just going to briefly discuss what is renewable energy, and we'll be able to define it at the end of Part 1. Pretty short section today. So renewable energy, a big idea behind renewable energy is that renewable energy can be rapidly regenerated, and some can never even be depleted, no matter how much of the energy resource that we use. Okay, so again, no matter how quickly that energy source is transformed and used into and transformed into something new, it won't be depleted. That source will some sources will never be depleted. Others will be replaced just as quickly as they're being used. Some energy sources are potentially renewable, and that means that the energy source is renewable as long as the resource is not consumed more quickly than it can be replenished. For example, biomass is a great example here. So if used in a sustainable manner, biomass can be considered a renewable resource. However, biomass can be consumed more quickly than it's produced, and so if that's the case, then it would be considered a non-renewable resource. Lastly, to just talk about what does it mean to be non-depletable. Non-depletable is no matter how much energy is captured, there will always be more available. And so many of your traditional energy sources that you think of, like wind and solar, geothermal, hydroelectric, all of those are considered non-depletable energy resources. And so again, we've got a picture of the many different kinds of energy resources that you think of. All at the top in orange are non-renewable. So again, we've got our coal, oil, natural gas from Chapter 12, along with nuclear power. Nuclear power, again, not a fossil fuel, but it is a non-renewable energy resource because the amount of uranium on Earth is limited, and we are using that faster than it's being produced. And potentially renewable, we've got wood and biofuel. So again, depending on how quickly we're burning the wood and how quickly we're using the biofuel, that source could potentially be considered renewable. And then we've got non-depletable. So again, wind, geothermal, solar, and hydroelectric. This graph here, figure 13.2, this shows us total global energy use in 2007. So you can see of the 492 exajoules of energy that was used all over the world in 2007, 87% of that energy came from non-renewable resources. So only 13% of the energy use on Earth globally came from renewable energy resources. And if we break that 13% down into a smaller portion, as you can see over here, we can see that most of that renewable energy came from combustible renewables and waste. So only a very small fraction, 15%, came from hydroelectric, and only 8% combined with solar, wind, and geothermal. So compare this graph now to the graph showing the U.S. energy use in 2008. So the U.S., 93% of our energy use came from non-renewable energy sources. That's up 6% from the global average. So that means that our renewable energy only accounted for 7%. And if we break that down, we can see that a little bit over half of that renewable energy is considered biomass. A good amount, about a third of that, is hydroelectric, with also a little bit of solar, a little bit of geothermal, and a little bit of wind as well. So we've reached the end of our checkpoints here. We've got our 3 questions. What are some common kinds of non-depletable, potentially renewable, and non-renewable energy resources? How do you know if an energy resource is non-depletable and potentially renewable or non-renewable? And what are the most important differences between renewable and non-renewable energy resources? Go ahead and answer these checkpoints, and when you're done, you can move on to Part 2.